Now today we solve question number 9 from exercise 1.2. So before starting question number 9, we discuss some double angle formulae in terms of tan. So we know that sin 2 theta is equal to 2 tan theta upon 1 plus tan square theta. That is sin in terms of tan, then cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta, and third tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta, which we already discussed in trigonometric function chapter. We also prove the properties. So here we have to use these three formulas to solve the question number 9. So see the first sub question. Now see first sub question. Cos inverse of 1 minus x square upon 1 plus x square. We have to differentiate this given function. So before differentiating the given function, we simplify first. So for that, observe this bracket 1 minus x square upon 1 plus x square. If we replace this x by tan theta, we get 1 minus tan square theta upon 1 plus tan square theta. That means this bracket we write in the form of cos. So for that we substitute x is equal to tan theta. So write in solution, let y is equal to cos inverse of 1 minus x square upon 1 plus x square. For reducing this bracket in terms of cos, we substitute x is equal to tan theta. So as to get 1 minus tan square theta upon 1 plus tan square theta, then we replace this by cos 2 theta. So we put x is equal to tan theta. Therefore, from this theta is equal to tan inverse of x. So right here, therefore y is equal to cos inverse of 1 minus, we put x as tan theta. So we write here tan theta is square. So we write here tan square theta upon 1 plus tan theta bracket square. So we write here tan square theta, which is equal to cos inverse in bracket. So 1 minus tan square theta upon 1 plus tan square theta, we replace by cos 2 theta. So we write here in bracket cos 2 theta, and we know the property cos inverse of cos theta is equal to theta. So we write this as 2 theta, y is equal to 2 theta. Now replace the value of theta, that is in terms of x. So we write here 2 into tan inverse of x. So we differentiate this function, differentiate with respect to x. So derivative of y with respect to x is dy by dx. 2 is constant, which is with function tan inverse x. So we find a derivative of tan inverse x. Derivative of tan inverse x is 1 upon 1 plus x square. So you have to write here reason. Theta is equal to tan inverse x d by dx of tan inverse x is equal to 1 upon 1 plus x square. So we get here 2 upon 1 plus x square as a derivative of given function. Now see second sub question, which is similar to sub question 1, but here instead of tan inverse in first sub question, cos inverse is given. Now outer function is tan inverse. So in bracket we require tan. So see the double angle formula for tan. So tan 2 theta equals to 2 tan theta upon 1 minus tan square theta. That means when we replace this x by this tan theta, we get 2 tan theta upon 1 minus tan square theta. See here, when we replace x by tan theta, we get 2 tan theta upon 1 minus tan square theta, which we replace by tan 2 theta. So we write here in solution, let y is equal to given function tan inverse 2x upon 1 minus x square. So write, put x equals to tan theta, therefore tan theta is tan inverse of x. So we write here y equals to tan inverse of, we write x as tan theta, so we get in numerator 2 tan theta, in denominator we get 1 minus tan square theta. So write tan inverse as it is. We write this bracket as 2 tan theta. So write here in bracket 2 tan theta, tan 2 theta. So tan inverse tan get cancelled by the property tan inverse of tan theta is equals to theta. So we write this as 2 theta. Therefore differentiate with respect to x. So before differentiating, we replace this theta by tan inverse of x. So write here 2 into tan inverse of x. Differentiate with respect to x. Therefore derivative of y is dy by dx is equals to, now 2 is constant, which is with function tan inverse x. Now find the derivative of tan inverse x, which is 1 upon 1 plus x square. So we get derivative of given function as 2 upon 1 plus x square. So in this way you have to solve sub question second with the help of this third formula, tan 2 theta equals to 2 tan theta upon 1 minus tan square theta. Now see third sub question, sin inverse of 1 minus x square upon 1 plus x square. Now observe the bracket first. It is of the form 1 minus tan square theta upon 1 plus tan square theta. But we know that this 1 minus tan square theta upon 1 plus tan square theta can be written as cos 2 theta. No problem, we can convert this cos in terms of sin because outer function is sin. So for that we have to use the formula cos of pi by 2 minus theta is equals to sin theta, or sin theta is equals to cos of, or you can write here pi by 2 minus theta. When we have to convert cos in terms of sin or sin in terms of cos, so you can use these two formulas. Cos theta is equals to sin of pi by 2 minus theta. So in place of sin inverse there may be cos inverse. In place of this 1 minus x square upon 1 plus x square, there may be value 2 tan 2x upon 1 plus x square. That time you have to reduce that sign in terms of cos. Here we replace this bracket in terms of sin. So first we get this bracket in terms of cos. So see here procedure. In solution we write here, let y is equals to sin inverse of 1 minus x square upon 1 plus x square. So put x is equals to tan theta, therefore theta is equals to tan inverse of x. Therefore y is equals to, here outer function is sin inverse, so sin inverse of 1 minus tan square theta upon 1 plus tan square theta. So we write this as sin inverse of this 1 minus tan square theta upon 1 plus tan square theta is cos 2 theta. So we write here cos 2 theta. But here outer function is sin, inner function is cos. So we have to convert this cos in terms of sin. So for that cos theta can be written as sin pi by 2 minus theta. So we write here y is equals to sin inverse of, in place of, now see here, in place of theta we have 2 theta. So where there is theta we have to replace that theta by 2 theta. So we write here sin inverse of sin of pi by 2 minus 2 theta. So here sin inverse sin get cancelled, we get pi by 2 minus 2 theta as a value of y. So you write here one more formula, sin inverse of sin theta is equals to theta. Now we differentiate this function with respect to x, differentiate with respect to x. So before differentiating this function, we have to replace this theta in terms of x. So we write here y as pi by 2 minus 2 into tan inverse of x. So after differentiating, we get derivative of y as dy by dx. Pi by 2 is a single constant, that means derivative of first term minus derivative of second term. So derivative of first term is 0 minus 2 into derivative of tan inverse x is 1 upon 1 plus x square. So here we get a derivative as minus 2 upon 1 plus x square. So in this way, first we reduce this bracket in terms of cos, and by using this formula cos theta equals to sin pi by 2 minus theta, we convert that cos in terms of sin. In some problem we convert this cos in terms of sin. Here we convert here at this step this cos 2 theta in terms of sin pi by 2 minus 2 theta. So you can differentiate the given function in this way. So write this. Now see sub-question 4, sin inverse of 2x in root 1 minus x square. Now first 3 example based on sin 2 theta, cos 2 theta, tan 2 theta in terms of tan, and here this bracket has root 1 minus x square. So how to substitute here value we discuss first, then we solve this problem. We know the derivative of sin inverse x. Derivative of sin inverse x is 1 upon under root 1 minus x square. We know the derivative of cos inverse x, which is minus 1 upon under root 1 minus x square. That means when you see root 1 minus x square in problem, then you have to substitute that x as sin theta or that x as cos theta. So here see, when we put x is equals to tan theta, we get the formula for d by dx of tan inverse x. Derivative of tan inverse x is 1 upon 1 plus x square. That means when we see in example 1 plus x square, then we substitute x is equals to tan theta. Similarly, d by dx of cot inverse x is equals to minus 1 upon 1 plus x square. That means when we see 1 plus x square, in example that type we substitute x equals to tan theta or x is equals to cot theta, and we know the third formula, d by dx of sec inverse x, d by dx of cosec inverse x. Derivative of sec inverse x is 1 upon x into under root x square minus 1, and derivative of cosec inverse x is minus 1 upon x into under root x square minus 1. So don't confuse with 1 minus x square and here x square minus 1. That means in example, if x square minus 1 is given, that time we have to put x is equals to sec theta or x equals to cosec theta. Here in our example, value is in root 1 minus x square. So we have to put x is equals to sin theta or x equals to cos theta. So see the procedure here. So first we represent the given function as y. So write in solution, let y is equals to sin inverse of 2x in root 1 minus x square. So we put here x is equals to sin x. So we write here, put x is equals to sin theta. Here value is in the form 1 minus x square. So we substitute x equals to sin theta or x equals to cos theta. So we prepare here x as sin theta. So from this we write theta is equals to sin inverse of x. Therefore y is equals to sin inverse of 2 into, in place of this x also we have to substitute sin theta, so we write 2 sin theta, in root we write 1 minus, we replace this x by sin theta, so we write here 1 minus sin square theta, so write sin inverse of 2 sin theta. Here 1 minus sin square theta, by using identity we write 1 minus sin square theta as cos square theta, so we write in root cos square theta, sin inverse of 2 sin theta into this square and square root get cancelled, so we write here cos theta, so we write here sin inverse of, this is a double angle formula, 2 sin theta into cos theta can be written as sin 2 theta. So sin inverse and sin get cancelled, so we write this as 2 theta. Now replace this theta by sin inverse of x, so we write 2 into sin inverse of x. Now differentiate this y with respect to x, differentiate with respect to x. Therefore dy by dx is equals to 2 into derivative of sin inverse x is 1 upon under root 1 minus x square. So in this way, by substituting x equals to sin theta, we find derivative of this given function. You can substitute x is equals to cos theta, you get same derivative. So we see that also. Now we solve this by the substitution. Instead of x equals to sin theta, by the substitution x equals to cos theta. So we write here alternate substitution. So we write here put x is equals to cos theta. When we put x equals to cos theta, from this we get theta is equals to cos inverse of x. So we substitute here. Therefore y is equals to sin inverse of 2 into, we replace this x by, instead of sin theta by cos theta, so we write 2 cos theta in root 1 minus, so here in place of x we substitute cos theta, so we get here 1 minus cos square theta, so we write this as sin inverse of 2 cos theta in root 1 minus cos square theta is sin square theta. So this 2 cos theta as it is, here square and square root get cancelled, we get here square and square root get cancelled, so sin theta. So we write here sin inverse of this 2 sin theta into cos theta, we write here sin 2 theta. So sin inverse and sin get cancelled, we get 2 theta. So we replace this theta by cos inverse of x. Now we differentiate this function. So right here differentiate with respect to x. So derivative of y with respect to x is dy by dx. Keep 2 as it is. Derivative of cos inverse x is minus 1 upon under root 1 minus x square. That means here we get minus 2 upon under root 1 minus x square. Here we get derivative 2 into, or you can write here 2 upon under root 1 minus x square. Here sign is positive, here sign is negative. So we write a derivative of given function as dy by dx is equals to plus or minus 2 upon under root 1 minus x square. So in this way you have to solve sub question 4 by using the identity and by substitution x equals to sin theta or x is equals to cos theta. Now see sub question 5th. Observe the bracket terms. So first see here cos inverse of 3x minus 4x cube. Now we observe the bracket here. Here value 3x minus 4x cube. When we replace this x by sin theta, we get here 3 sin theta minus 4 sin cube theta, which is triple angle formula. So we know the triple angle formula. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. That means when we replace this x by sin theta, we get in terms of bracket value as sin 3 theta. then we convert this sign in terms of cos, because cos is outer function. So we require in bracket also in the form of cos. So we write here in solution given function as y. So write let y is equal to cos inverse of 3x minus 4x cube. Put x is equal to sin theta, that means theta in terms of x. So we write theta is equal to sin inverse of x. Therefore y is equal to cos inverse of, replace this x by sin theta. So we write here 3 sin theta minus 4 sin cube theta. So write this bracket as sin 3 theta by using triple angle formula. So we write here instead of bracket sin 3 theta. Now outer function is cos inverse. So we have to use here property cos inverse of cos theta equals to theta. So for that we have to convert this sign in terms of cos. So for that we use here cos inverse of cos of pi by 2 minus 3 theta. That means we use here formula cos of pi by 2 minus theta is equal to sin theta. So we convert this sin theta in terms of cos theta. So we write here this cos inverse and cos get cancelled. So we get here pi by 2 minus 3 theta, which is value of y. So we convert this theta in terms of x first. So write pi by 2 minus 3 into theta, theta as sin inverse of x. Now we differentiate this function with respect to x. So write here differentiate with respect to x. Now derivative of y with respect to x is dy by dx. Here derivative of first term minus derivative of second term. First term is constant, so its derivative we write 0, minus 3 is constant but with sin inverse function. So we write 3 into derivative of sin inverse x is 1 upon under root 1 minus x square. So we get here derivative as minus 3 upon under root 1 minus x square. So in this way we have to reduce this bracket in terms of sin first, then converting this sin in terms of cos. So as to apply the formula cos inverse of cos theta equals to theta. So we use this formula cos of pi minus theta equals to sin theta. Then we differentiate the remaining terms. Now see next sub question. We have to differentiate cos inverse of e raised to the power x minus e raised to the power minus x upon e raised to the power x plus e raised to the power plus x. E raised to the power minus x. Now we solve this bracket. So first we solve this bracket because we already solved this example. Find the derivative of e raised to the power x minus e raised to the power minus x upon e raised to the power x plus e raised to the power minus x. In that example we write this power e raised to the power minus x as 1 upon e raised to the power plus x. So we simplify this bracket. So write in solution first let y is equal to cos inverse of e raised to the power x minus e raised to the power minus x upon e raised to the power x plus e raised to the power minus x. So first we simplify the bracket. So write e raised to the power x as it is minus this e raised to the power minus x. When we write in denominator we write 1 upon e raised to the power plus x upon, in denominator also we write e raised to the power x plus this e raised to the power minus x as 1 upon e raised to the power plus x. So write here square bracket. Now cross multiply in numerator and cross multiply in denominator. We get here cos inverse of e raised to the power x into e raised to the power x. We get e raised to the power x square minus 1 upon e raised to the power x. Similarly for denominator also we get here e raised to the power x into e raised to the power x. We get e raised to the power x square. So here instead of minus sign, sign is plus. So we write here plus 1 upon e raised to the power x. Now this e raised to the power x get cancelled with this e raised to the power x. So we write this as cos inverse of e raised to the power x its bracket square minus 1 upon e raised to the power x bracket square plus 1. So here we substitute or right here put e raised to the power x is equals to tan theta. So from this we write theta is equals to tan inverse of e raised to the power x. So we write here in bracket y is equals to cos inverse of tan square theta minus 1 upon tan square theta plus 1. So we take here minus sign in bracket, we write minus sign common. So we write here 1 minus tan square theta upon tan square theta plus 1, we write 1 plus tan square theta. So here we take minus sign from this numerator, so we interchange this term. So we write 1 at first position, this tan square theta at second position, and we change the sign of that two terms. Keep denominator as it is. For our convenience we interchange these two values. So we write here cos inverse of, now this is double angle formula for tan 2 theta. We know the formula, tan 2 theta is equal to here cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta, which we already discussed while solving the sub question 1. So here this 1 minus tan square theta and 1 plus tan square theta we replace by cos 2 theta. So write here minus cos 2 theta. So don't confuse with the formula cos of minus theta is equals to plus cos theta, not equals to minus cos theta is equals to cos of minus theta. So for this we have to use the formula cos inverse of, for converting this minus sign to plus sign we write cos of pi minus 2 theta. That means cos of 180 minus theta is minus cos theta. So you write here one more formula for your convenience. So we use here cos of pi minus x equals to minus cos x. So we write this minus cos x as cos pi minus x. Here instead of x we have 2 theta. So we write this minus cos 2 theta as cos of pi minus 2 theta. Now here cos inverse and cos get cancelled. So we write here y is equals to pi minus 2 theta. So we write this theta as tan inverse of e raised to the power x. So we differentiate this function, differentiate with respect to x. Now derivative of y is dy by dx. So write a derivative of y as dy by dx. Pi is a single constant, so its derivative is 0 minus, keep 2 as it is because this 2 is this tan inverse function. So find the derivative of tan inverse. Now this is composite function, and in inner bracket here is exponential function. That means we have to find two derivative of tan inverse and derivative of e raised to the power x. Now first we find the derivative of outer function. So derivative of tan inverse is 1 upon 1 plus x square. So instead of x we have e raised to the power x. So we write 1 upon 1 plus e raised to the power x square into derivative of e raised to the power x is e raised to the power x. So write here minus 2 into e raised to the power x upon 1 plus e raised to the power x its bracket square or e raised to the power 2x as a derivative of given function. So in this way we apply here two formulas. First formula is cos 2 theta equals to 1 minus tan square theta upon 1 plus tan square theta. Then we use here next formula cos of pi minus x equals to minus cos x, and substitution is e raised to the power x equals to tan theta. So in this way you have to solve sub question 6. Now see Sub question 7. Cos inverse of 1 minus 9 raised to the power x upon 1 plus 9 raised to the power x. So here outer function is cos inverse. That means we require cos in bracket. That means we have to reduce this bracket in terms of cos. Now observe the terms. Here terms are in the form of 1 minus tan square theta upon 1 plus tan square theta. But here value are not in the form of square. Now we observe this 9 which is square of 3. So we write this 9 as 3 square. So we write 9 raised to the power x as 3 square raised to the power x. That means we interchange this power because we write this 3 raised to the power 2x as 3 into 2x. That means 3 raised to the power x its square. So from this we get idea that this 3 raised to the power x can be written as tan theta. So we get here 1 minus tan square theta upon 1 plus tan square theta, that is formula for cos 2 theta. So we write here in solution, let y is equal to cos inverse of 1 minus 9 raised to the power x upon 1 plus 9 raised to the power x. So we write this 9 raised to the power x as 3 raised to the power x is bracket square. So see again what we have to do here. 9 can be written as 3 square. So we write here 3 square is bracket raised to the power x. So we write here a raised to the power m bracket raised to the power n as a raised to the power mn. Using this formula we write power in product form. So 2 into x. So we interchange this 2 into x. We can write x into 2 or 2 into x. So we write this as 3 raised to the power x its bracket square. So we write here cos inverse of 1 minus 3 raised to the power x its bracket square upon 1 plus 3 raised to the power x its bracket square. Now this convert in the form of 1 minus tan square theta upon 1 plus tan square theta. For that we have to put x 3 raised to the power x as tan theta. So we write here, therefore put x is equals to 3 raised to the power x is equals to tan theta. Therefore theta is equals to tan inverse of 3 raised to the power x. In previous example we put e raised to the power x. Here we put 3 raised to the power x as tan theta. Therefore y is equals to cos inverse of 1 minus tan square theta upon 1 plus tan square theta, which is equals to cos inverse of cos 2 theta. So cos inverse and cos get cancelled. So we get here y is equals to 2 theta. Now from this we substitute the value of theta as tan inverse of 3 raised to the power x. Now we differentiate this function, differentiate with respect to x. Now derivative of y with respect to x is dy by dx. 2 is constant which is with tan inverse. So we find the derivative of tan inverse which is 1 upon 1 plus x square. In place of x we have 3 raised to the power x its square. Then we have to find derivative of this 3 raised to the power x which is exponential function. So we write derivative of 3x as 3 raised to the power x into log 3. So the final derivative we get here 2 log 3 into 3 raised to the power x upon 1 plus 3 raised to the power x power 2. So we write 3 raised to the power 2x. So in this way we have to find the derivative of given function. So in this way you can solve the remaining questions with the help of these questions.